Welcome to the age of real iron. These bulldozers weren't built to impress. They were built to endure. No computers, no limits, just steel. Modern machines look smart. These were unstoppable. Number 1. Caterpillar D9. Few machines in history carry the same weight as the Caterpillar D9. Introduced in the 1950s, the original D9 and its later variants, the D9D and D9G, defined what a heavy bulldozer was supposed to be. Weighing over 45 tons and powered by massive inline-6 diesel engines, these machines were not built for finesse. They were built to dominate terrain that resisted everything else. The D9 became the bulldozer against which all others were measured, not because it was the most advanced, but because it refused to die. The heart of the D9 was its simplicity. Mechanical fuel injection, enormous cooling capacity, and conservative engine tuning meant it could run under extreme heat, dust, and load without self-destructing. Operators in mines, military zones, and remote construction sites trusted it because it did not rely on electronics or fragile systems. If the machine moved in the morning, it would still be pushing at night. Frames were thick cast steel, final drives were oversized, and track components were designed for punishment that would destroy lighter machines. What truly cemented the D9's reputation was where it worked. It became standard equipment in open-pit mining, large-scale earth-moving, and military engineering. Armored versions were used in combat zones because the base machine was strong enough to carry tons of added weight without structural failure. That alone says everything about its design margins. A bulldozer that can be armored and still function normally is not just strong, it is absurdly overbuilt. Even today, many D9D and D9G units from the 1960s and 1970s remain in service across the world. They survive not because they are economical, but because they are irreplaceable in attitude. Modern bulldozers may be more efficient, but none inspire the same confidence. The D9 was a machine that did not negotiate with terrain. It erased it. Number 2. Komatsu D355A. If Caterpillar defined American bulldozing power, Komatsu answered with the D355A, a machine that proved Japan could build iron just as brutal and enduring. Introduced in the late 1960s, the D355A was Komatsu's first true heavyweight, designed to challenge Caterpillar's dominance in mining and large-scale earth-moving. It succeeded by doing one thing exceptionally well: surviving abuse. The D355A weighed around 50 tons and was powered by a massive Komatsu SA6D155 engine. Like its Western rivals, the engine was understressed, tuned for torque and longevity rather than speed. The result was a bulldozer that could push relentlessly in heat, mud, dust, and stone without overheating or breaking itself apart. Its drivetrain was entirely mechanical, giving operators direct control and eliminating dependency on fragile electronics. What made the D355A legendary was not just its power, but its structural integrity. The frame, blade arms, and undercarriage were heavily reinforced, allowing it to operate in open-pit mines, where shock loads destroyed lesser machines. The D355A became especially famous in North America during the 1970s and 1980s, when mining companies realized it could run alongside Caterpillar's largest dozers and often cost less to keep alive. Its reputation reached pop culture when a heavily modified D355A was used in the infamous Killdozer incident in 2004. That event, extreme as it was, unintentionally proved the machine's raw durability. The base structure was so strong that it could be encased in armor and still function. Few modern machines could survive such modification without catastrophic failure. Many D355A units are still working today, decades after production ended. They endure because they were built with the assumption that breakdowns were unacceptable. In an era before global parts logistics and remote diagnostics, Komatsu engineers built a bulldozer that could be trusted in isolation. The D355A did not just move earth, it carried the philosophy that a machine's first duty is to survive. Number 3. Allis-Chalmers HD41. The Allis-Chalmers HD41 was one of the most brutally honest bulldozers ever built in North America. Introduced in the early 1960s, it was Allis-Chalmers' answer to Caterpillar's biggest machines, and it arrived with zero interest in subtlety. Weighing over 40 tons and powered by a massive 524 cubic inch turbocharged diesel engine, the HD41 was engineered for one environment: punishment. Mines, quarries, and dam projects became its natural habitat, where smaller dozers simply could not survive. What separated the HD41 from many competitors was its unapologetic mechanical design. There were no electronic controls, no delicate systems to fail under dust or heat. The torque converter, transmission, and final drives were enormous, designed to absorb shock loads from ripping solid rock or pushing against immovable faces. Operators described it as feeling more like a locomotive than a bulldozer. Once it started moving, it did not hesitate. Allis-Chalmers built the HD41 with structural margins that bordered on excessive. The main frame rails were thick cast steel, the blade arms were oversized, and the undercarriage components were massive, even by heavy dozer standards. This was a machine designed when field repair mattered. Remote mining operations could not afford downtime, so the HD41 was built to keep working even when abused, misused, and poorly maintained. In the 1960s and 1970s, HD41s were common on large infrastructure projects in North America, Australia, and parts of South America. They earned a reputation for being slow but unstoppable. While they lacked the refinement of later Caterpillar machines, they compensated with raw durability. Many operators preferred them because they trusted the iron more than any specification sheet. Even today, surviving HD41s still operate in niche roles, particularly in scrap yards and private earth-moving operations. They exist as proof of a time when manufacturers believed a bulldozer should be capable of enduring decades of structural stress without fatigue. The HD41 did not aim to impress, it aimed to outlast everything around it. Number 4. International Harvester, TD25. The International Harvester TD25 represents an era when agricultural and industrial machinery shared the same DNA: simple, overbuilt, and indifferent to hardship. Introduced in the mid-1950s, the TD25 quickly became one of the most respected heavy bulldozers in North America. With an operating weight exceeding 30 tons and powered by a massive inline-six diesel, it was designed for land clearing, logging, and heavy construction jobs where terrain was hostile and failure was expensive. What made the TD25 special was its mechanical purity. The machine used a direct, gear-driven transmission and clutch steering system that delivered immediate feedback. Operators could feel the load through the machine. There was no abstraction, no software layer. If the blade met resistance, the entire structure responded. That connection created trust. You always knew what the machine was doing, and it rarely surprised you. International Harvester engineered the TD25 for endurance. The engine was deliberately undertuned, prioritizing torque and longevity over speed. Cooling systems were oversized to prevent overheating in slow, heavy work. Final drives were thick, heavy, and shock-resistant. In logging operations where stumps and buried rock destroyed lighter machines, the TD25 earned a reputation for surviving impacts that would cripple competitors. The TD25 also became popular with farmers clearing land in remote regions. Its reliability meant it could operate far from dealer networks. If something failed, it could be repaired with basic tools. That mattered in an era when service trucks were days away, not hours. Many TD25s continued working into the 1990s and beyond, often passing through multiple owners. They became family machines, handed down, rebuilt, and trusted. Modern bulldozers may offer better efficiency, but few inspire the same confidence. The TD25 was built with the assumption that the world it worked in was unforgiving. And it was right. Old iron like this did not rely on promises. It relied on steel. Number 5. Fiat-Allis FD50. The Fiat-Allis FD50 was not built to compete politely. It was built to remind the world that Europe could produce a bulldozer every bit as brutal as anything from America or Japan. Introduced in the 1970s after Fiat absorbed Allis-Chalmers construction division, the FD50 became one of the largest and most intimidating dozers of its era. Weighing well over 70 tons, it entered a class reserved for the most extreme earth-moving operations: open-pit mines, massive dam projects, and terrain so resistant that conventional equipment simply failed. At its core was a colossal diesel engine producing torque in quantities that redefined heavy equipment. The FD50 was not fast, agile, or refined. It was deliberate. Every movement felt like a geological event. The drivetrain was engineered with enormous safety margins, using oversized gears, shafts, and housings that could absorb shock loads without cracking. Where modern machines rely on software to manage stress, the FD50 relied on mass. What made the FD50 legendary was how it handled sustained brutality. Mining operations often run equipment for long shifts under continuous load. Heat, dust, vibration, and constant impact destroy machines not designed for it. The FD50 thrived there. Its cooling systems were vast. Its frame was thick and rigid. Its blade arms could withstand forces that bent lesser dozers. Operators described it as slow but immortal. The FD50 also symbolized the final era of truly mechanical mega-dozers. There were no digital systems to fail. Everything was hydraulic or mechanical, accessible and understandable. When problems occurred, they were physical problems, leaks, wear, fatigue, not invisible software faults, that made the machine trustworthy in remote environments. Few FD50 units were produced compared to Caterpillar's giants, but those that exist are remembered. They proved that bulldozers could be engineered like battleships, massive, simple, and built to absorb punishment for decades. The FD50 did not adapt to the environment. It overwhelmed it. Number 6. Caterpillar D8K. If the D9 was the king of raw dominance, the Caterpillar D8K was the perfect embodiment of balanced brutality. Introduced in the 1970s, the D8K became one of the most respected bulldozers ever built. It occupied a critical middle ground, powerful enough for heavy mining and large-scale construction, yet versatile enough for land clearing, road building, and industrial work. Powered by Caterpillar's 3406 diesel engine, the D8K delivered enormous torque at low RPM. The engine was legendary for its durability, often running tens of thousands of hours before major overhaul. It was tuned conservatively, designed to work all day under load without stress. Cooling capacity was generous, allowing operation in deserts, jungles, and high-altitude sites without overheating. Structurally, the D8K reflected Caterpillar's old-school philosophy. The main frame was rigid and thick. Final drives were oversized. Track components were engineered for longevity rather than weight savings. This was a bulldozer built when manufacturers assumed abuse was normal, not exceptional. The D8K became a global workhorse. It was used on highway projects, pipelines, mines, and land reclamation sites across every continent. Operators trusted it because it behaved predictably. It did not surge, hesitate, or confuse. When you pushed, it pushed back with controlled force. Even decades after production ended, D8Ks remain active worldwide. Many have outlived multiple generations of newer machines. Their survival is not accidental. It is the result of design rooted in physical reality rather than efficiency targets. The D8K proved that a bulldozer did not need complexity to be capable. It needed strength, balance, and the will to endure. Number 7. Liebherr PR764. When Liebherr entered the heavyweight bulldozer market in the 1970s, it did not attempt to imitate Caterpillar or Komatsu. Instead, it applied European industrial logic, massive structures, conservative power delivery, and an obsession with longevity. The PR764 became the embodiment of that approach. It was not flashy, and it was never common. But in quarries and mines where it worked, it earned a reputation for being nearly indestructible. Weighing over 45 tons, the PR764 was built around a rigid box-section frame that resisted twisting under load. This mattered in quarry work, where uneven rock faces and constant shock loads fatigued lesser machines. Liebherr's engineering focused on distributing stress across the entire structure rather than concentrating it in vulnerable points. The result was a dozer that aged slowly, even under brutal conditions. Power came from a large diesel engine tuned for torque rather than speed. Like all true old iron machines, it was understressed. Operators rarely ran it near its limits, yet it delivered relentless pushing force. The hydrostatic drive system, unusual for heavy dozers of the time, was engineered with thick, robust components rather than lightweight, efficiency-focused parts. It gave the PR764 smooth, controlled movement without sacrificing durability. What made the PR764 special was how it handled long-term punishment. European quarries often run equipment for decades. The Liebherr was designed for that reality. Bearings, pins, and wear surfaces were oversized. Access panels made field service possible without dismantling half the machine. Everything about it suggested that engineers expected it to be rebuilt, not replaced. Many PR764 units remained in operation well into the 2000s. Some are still active today in private industrial operations. They survived because they were never optimized for short life cycles. They were optimized for existence in a world where machines were assets measured in generations, not lease terms. The PR764 proved that old iron was not just an American or Japanese philosophy. Across the Atlantic, engineers were building bulldozers with the same belief: if it cannot survive abuse, it is not finished. Number 8. John Deere 850. The John Deere 850 series represented a turning point for the company, marking its serious entry into the heavy bulldozer market. Introduced in the 1970s and refined through the 1980s and 1990s, the 850 was not the largest dozer in the world, but it became one of the most respected. It proved that durability did not require extreme size. It required disciplined engineering. The 850 was built around a powerful diesel engine that emphasized torque and longevity. Like the best machines of the era, it was conservatively tuned. Operators could work it hard all day without fearing thermal stress or premature wear. The transmission and final drives were thick, simple, and brutally honest. There was no illusion of sophistication. It did what it was commanded to do. What separated the 850 from many competitors was its structural resilience. The undercarriage was heavy and forgiving. The frame resisted fatigue in long-term land clearing work, where constant vibration and impact destroy lighter designs. Farmers, loggers, and contractors adopted the 850 because it behaved like a tool, not a device. It could be trusted far from dealer networks. In rural operations, the 850 became famous for its serviceability. Components were accessible. Systems were understandable. A skilled mechanic with basic equipment could keep it alive indefinitely. That trait alone defined old iron. The machine did not depend on infrastructure. It brought its own independence. Thousands of John Deere 850 bulldozers remained in service long after newer models arrived. Many still work today on private land, farms, and small construction sites. They continue because their value is not in efficiency, it is in certainty. When you start an old 850, you are not activating a system. You are waking a machine that knows exactly what it was built to do. Number 9. Case 1150C. The Case 1150C is one of the most underrated bulldozers of the old iron era. It never tried to dominate headlines or compete in the ultra-heavy class, yet it became a legend in the real world, on farms, in logging camps, on pipeline jobs, and in remote land-clearing operations where reliability mattered more than prestige. Introduced in the 1970s, the 1150C embodied everything that made old machines superior: mechanical honesty, structural strength, and the ability to work for decades with minimal support. At its core was a robust diesel engine tuned for low-end torque and long service life. Case engineers did not chase peak horsepower numbers. They designed the engine to live under load. It could idle for hours, push for entire shifts, and restart day after day without drama. Cooling systems were oversized, allowing the machine to operate in hot, dusty environments without overheating, an essential trait in forestry and agricultural work. The drivetrain of the 1150C was equally conservative. Mechanical transmissions and final drives were built thick, capable of absorbing shock loads from stumps, buried rock, and uneven terrain. Steering systems were simple and direct, giving operators precise feedback. There was no abstraction between human and machine. You felt what the blade felt. Structurally, the 1150C was far stronger than its size suggested. The frame resisted twisting in rough terrain. The undercarriage was heavy and forgiving, designed to survive vibration and impact over long periods. In logging operations, where machines were often abused by necessity, the Case earned respect for continuing to work even when visibly battered. The 1150C became popular precisely because it did not demand infrastructure. Owners in rural regions could maintain it themselves. Parts were mechanical, understandable, and rebuildable. A single machine could serve a family or small business for generations. Even today, thousands of Case 1150 bulldozers remain active. They do not impress with screens or modes. They impress with presence. They exist as proof that a bulldozer does not need evolution to be relevant. It needs integrity. Number 10. Caterpillar D7G. The Caterpillar D7G represents the perfect expression of mid-sized old iron. Introduced in the 1970s, it became one of the most widely respected bulldozers in the world. It was powerful enough for industrial work, yet versatile enough for agriculture, road building, and land development. More importantly, It embodied Caterpillar's pre-electronic philosophy: build it strong enough that it never needs excuses. Powered by a durable Caterpillar diesel, the D7G delivered consistent torque without strain. The engine was built to survive heat, dust, and constant load. It did not chase efficiency, it chased endurance. Operators often ran D7Gs for entire shifts at near constant output, year after year. The machine's structure reflected that expectation. The frame was rigid and thick. Final drives were oversized. Track systems were designed for longevity rather than weight savings. Nothing about the D7G felt temporary. It was a bulldozer meant to become part of the landscape. What made the D7G special was its universality. It worked everywhere, from Australian outback construction to North American forestry, from African infrastructure projects to Asian road building. The D7G became a global constant. It behaved the same in every environment: predictable, honest, indifferent to hardship. Even after production ended, D7Gs continued working for decades. Many still do. Their survival is not romantic, it is mechanical. They endure because they were engineered before planned obsolescence became normal. They were built when a machine's reputation mattered more than its release cycle. The D7G proved that old iron was not defined by size, it was defined by intent. These dozers didn't just move Earth. They moved history. They outlived trends, tech, and time itself. Modern machines evolve. Old iron endures.